welcome to today's Maniac Talk. As always, we want to have fun here. It's lunchtime, so enjoy your lunch. And of course, we'll have a good presentation from Jackie in a moment. Now, to transition to that, I wanted to talk about this donkey which was going home. Loaded, it was heavily loaded, meets with his friend here. Then I asked the donkey, by the way, why are you, hammering, you can't even breathe well? Then the donkey said, you know what, it's because of this load that I'm carrying. I said, well, let me show you how to deal with this. You put your staff down and then lap it up. Instead of using a rope, strong rope, to tie the load that was carried, I used the banana leaves, to carry the load. So when they did that, what happened is that the load that the donkey was carrying snapped and fell down. And then he told the donkey, you know what, you're carrying a lot. So we're going to remove all the load that you're carrying so that the load will be light. Okay? Then he said, oh, when the donkey, put back the load again, he said, oh, this feels much better. It's not like what I was carrying before. Anyway, to cut this story short, it's very interesting. It has a moral lesson. Now, in life, when we're dealing with public affairs, there are difficult things. Because they're difficult, don't overload yourself. Always try to balance life. Today's theme actually is going to work on. This team is going to work on Jack's talk today, whereby he has a very busy office, and without a doubt, you need to balance life at home, at work, so that you don't come to work shy or overshy, and then you cause havoc in other areas. To introduce Jack today is one of the colleagues who've been working with him at NASA headquarters, Alison Leitner. And she's been supporting the National Climate Assessment Program. Please help me welcome Alison Leitner.
Good afternoon. So I've been told that I should do a somewhat lighthearted and humorous introduction of Jack. But since he's my boss, I'm going to be just a little careful here. So rather than telling you, though, that he's been a senior manager at NASA for over 15 years and currently serves as the Associate Director for Research in the Earth Science Division, or that he has a BS in Chemistry from Adelphi University and a PhD from Caltech, or that he's been named a fellow of both the American Meteorological Society and the American Association for the Advancement of Science, or even noting his somewhat amazing collection of tie-ins, I'm instead going to comment on one of the traits that I think makes him a good manager, his humor. Jack has really an uncanny ability to make jokes on anything ranging from administrative procedures to science, and his jokes really range from spectroscopy to NASA conference and procedure forms, everyone's favorite topic, to the interagency process. So during this talk, I encourage you to pay close attention to what he says because I think you'll find a few jokes hidden there. So with that, I introduce Dr. Kaye.
It's really a privilege and an honor to be asked to do this. I've been, of course, lots of things that I may get to do, but to actually be told that I'm a maniac or something is different. But I'm not going to argue with that. And it is great to see so many people here, so many long-standing friends and colleagues. I won't say old because none of us are old. We're all just experienced. And I'll try to sort of just give a probably slightly different perspective from having been at Goddard and then not having been at Goddard. So give a different approach to what maybe these talks have been in the past. So the title is An Unlikely but Rewarding Journey from Quantum Chemistry to Earth Science Research Program Leadership. And I thought about doing this without PowerPoint, but decided that that was not going to work because I need that as a crutch more than anything else. And I'm not particularly creative, so you'll see a lot of words, but the hope is that the words are as much a reminder for me, and I will try to embellish the words with the things, especially that I didn't want to write down. And I guess I am being recorded, but Charles has said you actually will get final cut on the tape so that if you make the snarky asides that I usually make, we can actually have them removed from the from the final version, and if anybody watches online, there'll just be these telltale interruptions that'll really make people wonder what got taken out. So I'll start out with a little about me. Not that I'm that interesting, but I figure it's helpful background for what comes after that. A little bit about how I got where I am and maybe why I ended up that way. And then what I did and learned along the way, starting from my time at Goddard, my time managing a program at NASA headquarters, and my time running the RNA program, or whatever we called it at the time. And then I'd like to talk about some topics of interest that are just of interest to me, and hope they'll maybe ferment a little bit of discussion when we wrap up on training and career evolution. And I would just hazard a guess that I may be the first Maniac speaker who actually talks about training here. But I'm actually serious. Science at NASA, managing scientists, if that's not an oxymoron, and education and public outreach, and then a little bit about looking back and looking forward. So, start out, well, a little about me. There's a map of Long Island and the Long Island Railroad, because for most of my youth, other than a few weeks in the summers, I never got very far from Long Island. I get to Manhattan a little bit. From a point of early life history, I was born in Brooklyn, and yes, I'm old enough, the Dodgers actually were there when I was born. But my family was part of the exodus out to the suburbs, and I grew up in a sleepy little village on Long Island called Malvern. Went to school, and you can see that the mascot of the team was the Mules, which I'm sure people could have some fun with. And I lived at home for college, so at the Delphi University on Long Island. But because it was a New York area, it meant that I had access to a number of things. I was a train ride away from Manhattan, so from the time I was 12, I and my friends could go running off into Manhattan by ourselves, doing things that, sort of as a parent now, it's hard to imagine most any parent letting their 12-year-old just take the train in and go running around Manhattan. But we didn't know any better. We were close to the beach, and as a kid, I would get to spend a lot of time at the beaches, so I learned to enjoy that until later in life the ocean turned on me. Maybe we'll get to that later. As a Met fan, I learned suffering at an early age, which was probably very good preparation for a career in NASA management. Of course, the Mets actually did win occasionally, but that was the anomaly, and the frustration and suffering was what one really expected from them. So I didn't get much time off of Long Island until I left for Caltech to go get my PhD in chemistry. I'll say a little bit more about that. And I came back east after that, and people would ask why I left California. I mean, there's all the correct answers about job opportunities and stuff. I'll talk about the postdoc. But normally when people ask, I tell them I actually had to leave because I got deported for my third conviction for wearing a tie without a permit. It's a much more interesting answer than the true one. So I could say that I'm one of the few scientists in the family that emphasized law and business. My brother's a lawyer, my father was an accountant. Of a couple of uncles I had, two were lawyers, one was a stockbroker. So at family things, people didn't quite know what to say to me, which sometimes worked out because then they wouldn't, and I could go do something else. But it did mean that when my mother could talk about my son the lawyer, my son the doctor, well, it wasn't exactly the kind of doctor that impressed people, but it worked nevertheless. If I look back at my childhood, I would say I demonstrated great nerd potential without realizing it. And if I would sort of look at what makes for a happy childhood, I say one of them is sort of really being high on the nerdliness scale and having no idea that you are, in part because I had a peer group that had enough similar people. I'm the father of, I've been married for 30 years. My wife is a therapist. I guess I say, does anybody else have a spouse who's a therapist? Because that makes for some interesting discussions and dynamics at home. And it's given me a window into parts of the world that I would otherwise have never had any idea about, or at least realized I did. Father of 3 daughters, 2 are out of college, 1's in college. So most of the school year at this point we're empty nesters, which means I feel sorry for my wife because all she's got at home is me. Hobbies, people ask about hobbies, and the usual answer for that is I do laundry and I take out the trash. I like to try the New York Times, Sunday Times crossword puzzle, so I look at that as my weekly dose of intellectual and cultural humiliation. I've gotten better at it. And by instinct, I'm actually a pretty introverted person and reserved. But I actually like talking to audiences, which I think some people will find incongruous. And even when they're not captive audiences, but I do like to talk. It goes with, I think, being an introvert on the Myers-Briggs type indicator scale. So for those who are familiar with their Myers-Briggs type indicators, I'm an ISTJ, and if you're not familiar with it, we'll talk about training. You should go get trained and get tested and learn, because it's actually one of these instruments that really is useful and helps you understand, I think, how you may interact with the world differently from others. So the first time I did it, I was significantly but not completely introverted, but in the other areas, sensing versus intuition, thinking versus feeling, judging versus perceiving, I was completely, unilateral sort of. I was, if it was, 15 questions that would suggest one end and 0 the other, I was completely hard over on 3 of the 4 areas. So when I first did it, I said, great, if I die, you can put on my tombstone, no feeling, no intuition, no perception, no heartbeat. And I've done it since then, and it has not changed that much. So that's, if that means anything to you, that's sort of what I am. So how I got where I am and why. So being at headquarters, I have to turn everything into an Excel spreadsheet. So I tried to turn my life into an Excel spreadsheet, but I also tried to make it so that you couldn't actually read it. But I broke my life up into phases: before high school, college, graduate school, postdoc, Goddard, managing the program at headquarters, and Earth Science RNA, and put a little bit about education and training and some of the things that I was doing professionally, what was going on programmatically, some of which I was completely ignorant of at the time because I was working in a different field, and some of the interagency things, extracurricular things, and personal things. A couple of things to mention is that when you look at the education, there are 2 things that look like Earth Science in my, if you look at any of my transcripts. In New York State, 9th grade, science was Earth Science. So I have a year of Earth Science and it was a very innovative curriculum at the time, the Earth Science Curriculum Project. And my first year of college, I took a weather and man course, which was sort of a non-mathematical meteorology course taught by a paleontologist. That's what happens when you go to a small school. But he liked taking pictures of clouds, and he grew up on the farm in Missouri, so he had lots of them. And that's it. For formal training in Earth Science on my transcripts, that's all you're going to find. I actually audited some classes at Caltech in environmental and geological science, and that really had an enormous impact in changing my direction. So I started out from quantum chemistry, and I really did change fields. My degree was at quantum mechanics. That's about as much as I remember. It's a simplified version of the time-independent Schrödinger equation. But my undergraduate background was chemistry, lots of labs. In graduate school, I actually took relatively little chemistry. It was sort of, if you looked at it, it was more physics, applied math than chemistry. And of course, like you ask an organic chemist, they might grudgingly admit that I'm a chemist. Of course, you ask a physicist, they'll say, I don't know what the hell he is, but he's certainly not a physicist. But I was educated at this interface of chemistry, physics, applied mathematics, and computing. At Caltech, I did research. I did a lot of TAing in a variety of classes. I did a lot of computing, and had some interesting experiences working on Caltech computers, working on the remote computer up at Berkeley. We got one of the first, well, I think it was one of the first departmental mini supercomputers, or mini computers. We got a VAX, so I learned to help work on that. And then I had the unusual privilege of a lot of my production computing in graduate school was done, provided gratis to my advisor by a place called Ambassador College, which is in the west side of Pasadena, right along the spur of the 210 freeway. It doesn't exist anymore, but it was a great euphemism because Ambassador College was actually a higher education institute of the Worldwide Church of God. So if you ever remember the Plain Truth that was handed out at airports, or you've heard of Garner Ted Armstrong or His Holiness the Reverend Herbert W. Armstrong, most of the computing for my PhD thesis was supported by televangelists. There's a story there, but I won't take that much time. So when I was finishing up, I decided that I was more interested in using rate constants than calculating them. And the state of the art at that point was that, it was hard to calculate anything useful. So I thought using it would be more fun. I audited some classes in environmental and geological science in my 5th year of graduate school. Got exposed to a lot of work that I wouldn't otherwise known, including the guy, Darryl Strobel, who became my postdoc advisor at the Naval Research Lab. I would never have heard of him for not auditing a class. I think it was actually through Mark Allen at JPL that I found out about these classes at Caltech that I could audit. And Caltech being the kind of place that it was sort of like, hey, you want to go audit the class, come on in. Do some, do a little work. The NRC postdoc that I did at Naval Research Lab, I first learned about that program when I was in graduate school at Caltech. We were funded to do something called Dreyfus trips, because the Dreyfus Foundation funded them, to go and visit governmental and industrial laboratories, because there was a concern that too many people only would pursue academic careers, and they wanted to expose people to opportunities in government and industry. And I tried to hit a variety of places. A lot of people would go to Bell Labs or go to Brookhaven or something, especially the New Yorkers. They all went to Bell Labs and Brookhaven because it was a trip home. I wanted a more applied place, so I ended up at the Ballistics Research Lab at the Aberdeen Proving Ground, and because I thought I want to see an applied lab, and met somebody there who I think had been an NRC postdoc, told me about the program. I filed that away, found out about the program when I was at graduate school, and because at the time that was a postdoc program that paid real money. So it worked out well. And I had been interested in atmospheric science, so it wasn't a complete change. And then I did the postdoc at NRL, more planetary stuff than Earth stuff. But I was able to, relatively straightforward, make the transition from NRL to NASA. Part of what I'm calling the northward migration up 295, because especially Ricky Rood and Mark Schoberl had been in that group, and they'd already come up. And at that point, I'll say a little more about that, that the need was for what I would consider an atmospherically and computationally oriented chemist. And in some sense, what I had done in the past and what I was going to be doing was helping to solve large systems of coupled differential equations on a computer. So it wasn't a bad background to have. So the other transition that I made later on was from doing research to managing it. So I started out on a detail from Goddard, 4 days a week. One life lesson: if somebody says, 4 days a week, you have a day of the week to do something else, forget it. You're not going to do something else, at least not effectively. And I did that to gain breadth, exposure, visibility, and insight into how the system worked. Visibility was important because at the time, headquarters had a real central role in just everything that went on in atmospheric chemistry, and it was a good way to get noticed. But it was also a good way to get breadth, and so the depth versus breadth issue was something I'll come back to. I actually found that I liked that breadth, the scientific and programmatic, and the ability to interface with a broad variety of people. Not just the scientists, but I ended up working with education people and just a whole bunch of other stuff. And I really liked interfacing with a wide variety of people. And the people at headquarters seemed happy at my performance. So when I was presented with the opportunity to make a transition from Goddard to headquarters permanently, it was an easy decision for me. Now, there's a wrinkle in that at the time, around that time, I had also been offered an academic position and a tenured faculty position. And that was a little bit of a harder one to turn down, but in the end, I decided that, this is what I would do, and I think it worked out pretty well, or very well. So I haven't looked back, because sometimes people say, do you miss doing research? And the answer is, I miss being able to dig into things and learn things, but the doing the research, that doesn't bother me so much, because the role switched. I'm not what I would call doing science. I'd like to think I'm enabling science, although, when people write proposals and they get the letters over my signature declining the 80 or 90% of the proposals that come in, I don't always feel that I'm enabling. On a good day, one really can do that. It's planning and coordinating and a bunch of other things. And so I have to find value in those roles. I do. Say, as a program manager, and I could really help feel that I was getting a, sort of, when faced with doubt about, what do I do with the last few selections, say, help a young investigator get established and then maybe a few years later see that that really made a difference. That was very rewarding. You know, seeing other people's careers enhanced, in part, you know, maybe I helped a little bit. After a while, it gets hard to contemplate going back to actively doing science. I have a lot of respect for those who will, you know, say do the management for a while and then say, you know, I'm going to get back on the computer, back on the lab. I barely know where to start. I mean, I'm not quite so bad that I'd say, where's the card reader? But maybe not much better than that. So the challenge is to be comfortable with increasing breadth at the expense of depth, and especially in the current position. Now, as a program manager, there was a decent balance between breadth and depth. The current position that I have really emphasizes breadth at the expense of depth. And I may try to say, emphasize the breadth, but other less positively inclined people could say, that's not breadth, that's superficiality. And that's just the world in which I have to live and accept. So, okay, what are some of the things I did and learned along the way? And I will selectively acknowledge some of the people who helped me. So for those that I don't list and you feel you helped, sorry, I'm just not going to try and list everybody, but I will try to do that. So what about Goddard? I came to Goddard in December of '83, and like to say, I was hired to be the right-hand side of the Stratospheric General Circulation and Chemistry Modeling Project. Marv Geller was the PI. He's the one who really brought me here, though I think Mark Schoberl was the one who really helped make the connection. Interestingly enough, I came to Goddard and I think they gave me employee number 35 because I wondered, gee, who was it who died that I got that? But they must have recycled the number. So I started out working on the chemistry package, what was going to become a 3D model, did some 2D work, and Charlie Jackman was very, very helpful in giving me access to the 2D model so that I could do a bunch of things. And then I initialized using satellite data because the LIMS data had just came out, and Jordan Alpert was somebody who was really incredibly helpful in terms of helping me learn how to read these tapes, because at the time, you'd say, go to NSSDC, they'd send you a tape and they'd give you a manual and it's like, you're on your own. So it was really helpful. I should say, before I proceed, that coming into Goddard in that group, when I did, was just an incredibly marvelous time. You think about what was going on in stratospheric chemistry in the 1980s, the stuff that was happening, satellite data that were becoming available, network for detection of stratospheric change getting spun up, building towards a UR's launch, Nimbus 7 flying, SAGE being launched, ozone hole being discovered, Montreal Protocol being worked on, ozone transpanel. It was just a fabulous time to come into the field, and it was a wonderful group of people to come in with. I think, you walk up and down the hall there, and you look at who was at Goddard at the time and say, there's, I think at that time, and probably still true, no other institution that has such a collection of people who were very helpful and welcoming to me. Eventually, we got the 3D work spun up, so that Ricky Rudin was my dynamical counterpart, and then because we were tying into assimilation, we were able to work with the observed data. People used to say one nice thing about me working with Ricky was that if you averaged over the two of us, we actually talked about a normal speed. Rich Delarsky once told me that I was the second fastest speaker at NASA, and he didn't mean that as a compliment. And we can probably all figure out who the fastest speaker was. I got involved in URs through Marv Geller's theory team, and Skip Reber gave me a couple opportunities to talk at the UR science team meetings, and that helped provide a little visibility and reasons for me to dig into things. Mark Schoberl worked on an EOS interdisciplinary proposal, and I helped with that. That was when the definition of interdisciplinary meant 3 or more instruments even on the same platform. We hold people to a much higher standard on interdisciplinary now. But of course, back then, the chemist talking to the meteorologist was novel and interdisciplinary. I participated in an AASE theory team. Rich Delarsky was the PI for that. I went over partway through to spell Rich. We had another team, the Schoberl team, that was over there all along. So I briefly deployed to Stavanger, Norway. One of the things I learned is, I think, just how much field campaigns take out of people. because, you know, you got to see, you know, how hard people work, how hard people drove themselves. They were in the field. And you know, from having been there, I've never lost that lesson in the respect that I have for what people put them through when they do these things. You know, interesting story on that is, you know, I came back, I was probably pretty worn out from working, partly as, you know, nobody's going to outwork Mark Schobrow. So, you know, the hours were long. I came back, you know, I probably maybe didn't realize I was getting sick, but, you know, I was going to be in bright and early on Monday morning to, you know, bring in whatever chocolate I got from the airport and tell everybody about what was going on, because I was the first person who came back while the mission was still going on. Well, I was sick. I got dizzy. I felt faint. I went out in the hall. Somebody called Goddard Health Unit. They came over. They called Prince George's County paramedics, and they hauled me out on a stretcher and took me up to the PG hospital up on Good Luck Road. I wasn't there for very long, but Ricky got the pleasure of calling my wife and say, well, you know about Jack getting hauled out on a stretcher, don't you? And my wife said, well, no, tell me about it. You know, the flight programs really can take a lot out of people. I did some independent research on isotopically substituted molecules and vibrationally excited molecules. I had done some of that on a postdoc. I actually got to be sort of a, you know, recognized expert related to ozone photochemistry and some other areas. I wrote a review article on that. One of the reasons I sort of started working on the review article is I was asked to review a paper where somebody had looked at some isotopic stuff, and there was just, you know, really sloppy assumptions, and they're like, somebody should actually write this stuff down for atmospheric scientists. And, you know, a while later in a 50-page Reviews of Geophysics paper, you know, I did that, and it was fun to have an area that I was interested in, and maybe that was the hardest thing to let go. I served on and eventually chaired the computer user community committee here, and I did some AGU work. So it was a good time to be here, and you know, appreciate those who helped me out. And then somewhere around 1990 or so, I got a phone call from Dixon Butler, who said, you know, would you be interested in coming down and helping to run what then was the Upper Atmosphere Theory and Data Analysis program? And you know, I think to his surprise, and I think he was happy about it, I said, sure. Because sometimes I guess people look at headquarters as, you know, it's like you know, you don't want to be a member of any club that will have you, and it's like, you know, if someone actually wants to come to headquarters, you know, do we really want them? But I mean, he was very happy to have me come down there. Michael Prather had been doing it from GIST, Rich McPeters had been helping, I think Charlie Jackman had helped. A lot of people were really happy for somebody to be interested in doing this, so I went down to do this. You know, had some help along the way, and you know, I was brought in to take what was sort of largely a stratospheric chemistry program with a little dynamics and turned it into a more balanced atmospheric chemistry program with more troposphere, ultimately with more aerosols, to have a lot more 3 dimensions than 2 dimensions. So I was able to change the program a lot. I got schooled in headquarters management by Bob Murphy, and later by Bob Schiffer. Bob Murphy was always the fountain of, you know, pithy things like, you know, I can't remember exactly, but it's like never sign what you write and never write what you sign. And if you've never missed a flight, you're spending too much time in airports. I was asked to serve as program scientist for the Atlas series of shuttle missions. That was going to be 10 missions. It got truncated at 3, but that still wasn't bad. I think when I hope I'm being fair, but when people came to headquarters and someone said, can you do this program science role? And I said, sure, what's involved? And they gave me a sense of what might be involved, as they didn't quite give me the whole story. George Essenwein and Earl Montoya, who then worked in what was the old Code U, one day said, let's go to lunch, off-site. So we went over to the Holiday Inn for lunch, and they said, like, I don't know what they told you, Jack, but you're a program scientist for shuttle missions. You know, you're going to have to step it up in a big way. This is going to take a lot of your time and a lot of energy, and you're going to have to be like spending time every day thinking about this, you know. I said, well, gee, that's not what they told me. And it's like, I don't care what they told you. This is reality, Jack. You're going to have to step it up. You know, I always remember that and appreciate them doing that for me to sort of give me the attitude adjustment that I ended up needing, because it was a big deal, especially for Atlas II when we asked for a night launch. Asking for a night launch then was a big, big deal. And then over time, I picked up a variety of other program science responsibilities, TOMS, SAGE, SSBUV, MIDEX. I know Ernie Hilsenrath because as the SSBUV, we used to say he was NASA's most frequent flyer. We also got to spend a lot of quality time in Huntsville, and I mean that seriously. The MIDEX, you know, that one actually didn't come till later, and we know, unfortunately, how that ended. But one of the things is that the concept for, you know, doing, having the Israelis do aerosols from the shuttle really came out of conversations with PK, J. Herman, and Rich McPeters here at lunch at the Chinese restaurant in Greenbelt. That's actually sort of little documented, and maybe people would have just as soon forget that as to how that happened. I helped with some division-wide and education-based solicitations, worked on the CFC lifetime assessments, which stood the test of time for a while until it was just eclipsed by, I guess, you know, Paul Newman and some others did that. Worked on the first IGOS atmospheric chemistry plan and early participant in WCRP Spark, so got some international work. Did some interagency work for US GCRP. Then did some other international stuff with Russia, Mission to Planet Earth Joint Working Group, and that was really interesting at the time because that was early 90s was when you were sort of looking at the implosion of Soviet Union and the loss of a lot of their scientific, the investment that they were making in science, not in so much the human capability other than the people who came over here that we benefited from. But it was very interesting to be part of that. And say a little more. And then I did some training, the Council for Excellence in Government Fellows program, and I think I did the MIP Managing the Influence Process training, and I think they've stopped doing that when they've changed it, but MIP 4 was early. And then I took on what's sort of more or less my current position in 1999. Gautam Oswar selected me for what was then Director of the Research Division. The title and the organization have changed twice since, but the job actually hasn't changed that much. So I went from being a peer to being a supervisor of my former peers. Not always an easy thing to do. It worked pretty well in part because my management style was to, and deal with just my general approach to things, which is, you know, if you know what you need to do, go do it. I don't want to micromanage people. I don't want people telling me how to do my job. I don't want to tell people how to do their job. And it mostly worked. Over time, I was able to hire a significant fraction of the staff, provide some recognition. I've been fortunate in terms of, you know, the agency headquarters award process, served on a couple of agency task teams on science and interacting with the centers, which I still see as a very important part of my job. I was able to oversee some recompetitions of things that had been around in place, IDS and Terra Naqua, and a bunch of new things, so, you know, where especially we'd have a little budget growth and say, let's do something new. So we've actually been able to do some new things, airborne instrument technology transition, remote sensing theory, the international polio, some others, and of course on the less fun side, increased focus on financial performance, you know, obligation costing, you know, all these things that years ago I just don't remember thinking all that much about. Now we think about that like every day. Okay, been doing the same job mostly through 3 organizations, including a brief period of Earth-Sun. I thank Mary Cleve for, I think, helped looking out for me in those transitions. Worked on the Earth Science Enterprise Research Strategy back more than 10 years ago. And worked with our advisory committee and the NRC on that. I've been doing a lot of interagency work, mostly US GCRP. I worked on the NPO Senior User Advisory Group. There's things for oceans, things for Arctic. Dealt with administration transitions, and for a while, at the start of this administration, I was the acting director for the Subcommittee on Global Change Research for almost a year and a half. So I helped write what turned out to be the second National Climate Assessment, helped to lead NASA's involvement in the third NCA, although Allison's the one who actually spends like every day thinking about it. And I've got a bunch of international involvement. So there's some things. So, okay, so what are some topics of interest that I'd like to say a little bit about? First one, training and career evolution. You know, what are scientists' ideas about training? You know, the best possible spin, I would say, is investing in oneself. Or, you know, some people might look at it as ticket punching. You know, if I got to do it to get something, I'll go and do it, but maybe not with any enthusiasm. A logical response for a lot of people is, who has the time? You know, some people, especially when I became SES and we go up, people say, you're going to charm school. And I'd say, no, I'm already charming. I would tell people what it really is it's to turn me from being one of us into being one of them. Not actually true. So, you know, you find different views on training, especially at headquarters when we push for people. And, you know, some of it is to say, learn about, you know, the bigger picture, learn about how organizations function, learn about the political process. And, you know, some people would say, well, why can't I just go to a different scientific meeting and, you know, broaden myself disciplinarily as opposed to these other parts of my life? You know, I'm a believer in it. I think that the training can help scientists fill in gaps in their education. If, you know, for a lot of us, if you're probably like me, in college you weren't going out of your way to take electives. It would be like, more math, I can take more math. So that's what we would do. So, you know, there's a lot of us that are probably somewhat, you know, ignorant about a lot of other things, even where there's actually, you know, rigor and discipline associated with it. Training can help open your eyes to opportunities and career paths that you wouldn't know about otherwise. I don't know if I hadn't done that Council for Excellence in Government Fellows program, whether I would have even tried to put in for the director position that I got, because it really got me thinking about management and thinking about, you know, what I might do if I were in that kind of role. And I must have wanted it because I had to apply twice to get the position. Training can be important if you want to maintain flexibility or potential opportunities within the government. You know, certainly if you want to be SES, if you haven't done it, that will be held against you. I was on a panel once and I could see very visible action of that, an otherwise perfectly qualified candidate, and somebody said, well, what training has he done? He hasn't done any training. He must not be very interested in this stuff. He's out. So, you know, if you want to, you know, I'm not a big fan of doing training for ticket punching, but if you want to maintain flexibility, it's not a bad thing to do. Finding time for training can be challenging, and in general, for a lot of you, if you say, well, you know, a lot of us who say, well, I'll do it when things calm down. That's never going to happen. So, you know, if you're going to want to do it, you're going to have to do it and make an effort out of it. Now, just because you go to training doesn't mean it's actually to incorporate into your everyday life the things that you learn in training. I find that really hard. And there are good opportunities for training within and outside the government. You know, my sense is information can be hard to find. You know, it's very hard even if you would say, well, who went to a training? You know, where do you go to find out? Say, did anybody go? What did they think of it? The training budgets are limited, so sometimes says, yeah, really look at training, except if, unless it doesn't, you know, unless it costs something. So there's sort of mixed messages, and in some cases the processes are complex and burdensome. Even to go to like a one-week training, you have to fill out an application and get interviewed and all that stuff, and it's like, if you have to work that hard to do something, do you really want to do it? So you end up with, I think, a lot of scientists who don't do that. And I never know how much to extrapolate from one data point, but a number of years ago I was on the review panel for the SES Candidate Development Program. And by my definition, of like the 70-some-odd applicants agency-wide, none were scientists. Now I don't know whether it's that they didn't put in or they put in and got pulled out at the agency level. Now somebody said there was one from Monsanto who was a scientist, but all their degrees were engineering, so to me, I count them as an engineer. But, you know, scientists, at least at NASA, tend not to take advantage of that. Some other things, science at NASA, is a subject that people I'm sure have thought about. That, you know, as far as I can tell, NASA is very unusual in having significant intramural and extramural research programs, and essentially unique in terms of competing most of it together. The NASA centers vary in approach. You know, JPL doesn't have civil servants. Some of the centers are bigger and have projects that people can leverage. Some centers are smaller and don't. Most NASA scientists do what I would consider enabling work, and their science. And I think the consensus is that in general, NASA and the community are really well served when people do both. It's not all one and it's not all the other. I think our stakeholders and the external community have come to expect the current approach. When people talked about going to unified labor, Congress said, no, we don't want to do that. And there's a competition metric that we used to have, at least as OMB, and if we didn't compete certain fractions of the program, we'd have to grovel why we didn't do that. So it's not something you can necessarily change, and of course the rest of the community that's competing for the same pot of money likes to think that people are competing. Well, we've been looking at it. There's been an agency team on that. There's setting up something called SERA, Science Enabling Research Activity. We've actually been doing some of that already in earth science. There's some particular issues with, you can find, I'm sure, find people on both sides. Redacting civil service cost information from proposals complicates reviews. It's not in the budgets. It makes it hard for us to deal with things afterwards because sometimes, it's just hard to get all that information on time. There are challenges at the centers. Bridge funding and GOLD, or Directed Research and Technology, I guess is the new name. And we say Directed Research and Technology. Please don't abbreviate it as DIRT. It's provided some help, but it's introduced some management challenges because, say in the context of bridge funding, if people actually know what that is, that's money that kind of comes off the top of my program, and you have to send this much money to this center and that will pay this people. So that's money that I lose access to. So being sort of the controlling SOB that I sometimes am, I'll say, all right, if I'm paying those people off the top and I have no choice, then they work for me. I want to know who they are and what they're doing, and why they're on bridge funding. But so that creates the issue where the alignment of headquarters and center management, I think, is becoming increasingly important when you deal with these kinds of issues. It's not built into the system, so it's very dependent on people and personal relationships. And I think in general, I've been very fortunate that I've been able to have good, positive discussions with the centers, with back and forth about these kinds of things, so it doesn't become adversarial in the way that it has the potential to be. So that's why I think spending time at the centers when I can and getting talking to people is something that's important to what I do. Managing scientists, what one might say, is there even an issue? Are scientists any different from anybody else? If they're not different from everybody else, then I can skip over this. But maybe there are some differences. And my experience is more from managing managers as opposed to managing researchers. So maybe I should be careful about extrapolating. My sense is that scientists tend to be much more outwardly focused. What does the community think of you? That's where sort of the reward system and the recognition come in, not necessarily what does my own management think of me. Especially because at NASA that, there's limited things that one's own management can actually, can do. The PI role is significant, and the ability to interact with that external community is significant. And I think in a lot of other areas, you don't see that. People may worry more about their line management, but you don't compare yourself to people in other organizations, because what's the basis for comparison? It's much easier for us in science to sort of do that. I would say that scientists seem less prone to have what I would consider as automatic respect for authority, and they're happy to have management help them get resources or help get them resources. And I think sometimes do appreciate the buffering when they actually realize that they're getting buffered. And a lot of times people think, my God, if we're getting buffered, how much worse must it actually be? But I think sometimes that the sense that people care passionately about things and sort of like, where they may feel that something's the right thing to do, and if management doesn't go along, they're right and management is wrong. But we have to make decisions and move on. But I think the sense is that a lot of folks just see that as the basis of, that's the start of the discussion. We tend to be very specialized, and I think that means mostly correctly that the people who are doing science know more about what they're doing than their management does. And each successive level up the chain, apologies to those who are managers, it gets more and more true. So that by the time you get higher up, people, they may think they know something. And they probably know something, but not a lot. The experts are the ones doing the work. Say many scientists, and I think it's particularly true at NASA, are very committed to what they do and will push themselves to accomplish more. So what's the dynamic, especially these days? Well, you want to do more, you write proposals, you build up a bigger group, you have to support it, you write more proposals, and you get into this kind of, I'll call it a positive feedback in the sense of a feedback, but it's not necessarily particularly positive because of that. But I think as my boss Mike Freilich once said, that scientists dislike writing proposals less than they dislike not being able to do the work. You know, you say, well, who says people have to write so many proposals? Nobody really does. People say that themselves. That's a challenge. I think, you know, providing opportunities, especially good nurturing opportunities for new scientists, young scientists who come in, is challenging. I'm not sure we do it terribly well. I was really fortunate when I came to Goddard because of the way it worked. I was 100% full-time on Marv Geller's program, and nobody was asking me to write proposals the minute I walked in the door. I think the sense is a couple of years I'd start being a co-I, maybe a few years I could propose to be a PI, but there was no rush. It was a very good way to come in to the center. And most of the centers right now, that's not how people come in. You know, for a lot of them, you know, it's like the minute they walk in the door, no matter how junior, it's like, start recovering. Talk about that. Getting scientists to consider alternative career paths can be challenging. I did that. I think it's a good thing for some. It's not a good thing for everybody. But somebody's got to do it. And you know, the hope is that when people do it, the community will respect and you know, at least grudgingly acknowledge the efforts of those who do that, and not sort of look at it as, you know, sort of like, you know, those who can't do teach and those who can't teach. You know, that's not the way it works. That's not how the community looks at program managers. I think at NASA we actually do pretty well. I think, you know, because most of us, you know, we're scientists who manage. We're not managers, and probably sometimes that may show up in our costing metrics and things. Last, education and public outreach. They're really different things, but people tend to lump them together. So I will too, but then I'll separate them. So public outreach, I'm a firm believer that the job is not done until the message, you know, the message gets out. And that means getting out to a variety of people, to management, sponsors, stakeholders, public. That means we need different products for different people. One of the things that we get to do at headquarters is ask, and I'm sure it seems like we ask a lot. Communicating results is not easy. It's harder for some activities than others, and it seems especially hard in earth science. It's kind of what I call the logarithmic derivative effect, delta knowledge over knowledge. You know, you go for some other things, some other areas, you know, it's much easier to have a high delta knowledge over knowledge because they just don't know as much. You know, you can actually do a first. You know, the first extrasolar planet that has this kind of characteristic. You know, we can do that stuff really well. You know, our firsts are more limited. Scientists, I think, are much better at saying what they don't know than in saying what they've learned. You know, in some cases, it's much easier to get a scientist to tell you what the 2 second-order questions are after they've solved the first-order question, but they won't tell you they solved the first-order question. They'll tell you what the next questions are. I think it's just hard sometimes to really get people to say, here's what we learned. And then, so for me, you know, having appropriately formatted results to feed up the chain becomes a challenge, and getting them in a timely way. The good news is that at NASA, we have enormous capability. We've got enormous human talent. We've got products that come out of a variety of things, you know, Science Visualization Studio and others. We've got the Hyperwall. We've got the NASA brand. Just the fact that we can have the NASA meatball, it goes a long, long way. You know, there's, I think, no other agency in the government where that insignia, you know, carries as much weight. You know, it's like we may put the NASA lapel pin on our jackets, you know. You know, if you work for the IRS, you're probably not happy, not quite so happy to do that. And people want that stuff. You know, and as an agency, we've got a lot of management support for our efforts that we have not had before, and that is just so incredibly gratifying. You know, the Earth Right Now campaign and things, it's really, really nice to know that, you know, it's like, you know, we don't feel like we're fighting the system to promote what we're learning. We have a particular challenge in earth science because not everybody likes what we're learning, and we're not the only ones doing this. So sometimes it's like, you know, we compete for bandwidth with our partners, and then there are people who it's like, you know, they just don't want to know it. And, but the flip side of that challenge is the opportunity is that we're talking about stuff that really matters. So we just have to deal with that. say that, the job's not done until the message gets out. Not everybody has to do everything, If you're really not good at it, you'd probably back off. But at the portfolio level, if somebody does less, somebody may have to do a little more. And if you're good at it and you like it, you probably want to make sure you don't do too much of it, because then, you're not going to be doing science. And then for education, I feel that we all have a responsibility to inspire, educate, and train, but not just the next generation of scientists, but also the next generation of citizens and voters. And this is some cases where it sort of put me at odds a little bit with some of historical NASA management, which is, it's all about training the next generation of scientists. And I feel, no, we need to help educate the next generation of citizens. The education is not just Earth system science, it's not just meteorology, or oceanography, whatever, because, there's disciplines like chemistry and physics and biology and math and computing. And, I think we provide opportunities for people to really, help illustrate the concepts that they're learning about and apply them in interesting ways. So we have a particular need to reach out to the broadest possible pool of students, not just with the traditional sources of workers, addressing diversity in all its forms. I've been able to do that at NASA, maybe a little less now than we did in the past. I applaud Franco Ainati, who's taken on that role into retirement to really, really try to reach out to students and institutions that don't otherwise necessarily know a lot about what we do. I think we need to find a more effective way of sustainably interacting with the education programs. That's something I just think we can do better. There's a new AA coming into NASA education, so I'm hopeful. The connection used to be better, it's less good now. And I think when the opportunity presents itself, it's important that we do what we can. So, the speakers bureaus and stuff like that, I'm a big believer in that kind of thing. So, okay, looking backwards, looking forwards. So I think my career has been pretty successful. I'm happy with the way it's gone. It helped, I think, that I had a good solid background in physical sciences, math, and computing. But also the fact that I was willing to explore something different. I had some opportunities to do it, and then I did it. It was a risk, but I think it worked out. It was real fortunate that I encountered some people along the way who helped me out. I mentioned a number of them, not all of them. I had to really get out of my comfort zone twice, from being a chemist to being sort of a modeler, and from being a researcher to being a manager. And the training actually did help, especially in terms of making that transition into management. I have a family that, in general, has been exceedingly supportive in juggling the personal and the professional. That's one of the things that's really hard for me. And at the time I came to headquarters, when I was really juggling with the young family kind of thing, and it's people tolerate it a lot, encourage me, and I think we're happy when I was successful, and that was just really important. I had a staff. Especially in the current position, people work really hard. People are passionate, they care about what they do in general, they're very good at it. I've had colleagues who've been good partners, and a highly productive research community, because in the end, all the results I talk about are theirs and yours. They're not mine, So I don't create results. I create, PowerPoint and Excel, and an occasional Word document. So that community has been mostly appreciative, and management, I've mentioned a number of people, Dixon Butler, Bob Murphy, working away, Charlie Kendall, Mary Cleve, Mike Freilich now. They've provided resources, encouragement, direction, flexibility, and some rewards too. I've been well served by the government. So what's in the future? I talked a little bit about some concerns for NASA. For me, the last time somebody asked me that question I was talking, I think was like the AMS policy, Summer Policy Institute. And then, I hadn't really thought about that for a while. So they said, what's next for you? I said, well, thought about it, long-term care insurance. I did that. So after 30 years at NASA, I'm still committed to what I do. And two things, when you hit 30 years in the federal government, it means people start sort of looking at you. You still here? How much longer you got? I go to my doctor, he'll say that, my physician. So you get that a lot, but on the other hand, scientists tend not to retire. Somebody was saying, like, you go touch a resource person or something, and they'll tell you exactly how many years they have left. The scientists either don't know, or they just leave and they come back. There's very few people who actually retire from this business and then go away. I learned, I think I'm continuing to grow and learn and grow as a manager, especially when I need to push. I'm a much better boss for people who really don't need close supervision than I am for those who do. For those that I need to sit on, I'm just not very good at it. I'm getting better. Fortunately, there's not that many that I've really felt I had to push on. Growing as a scientist may be more of a challenge because it's like, I don't read journals. I'm sorry. If I'm lucky, I can get to science. If you send me a preprint, I might look at it. I'm old-fashioned. I'll bring it on the airplane if I can. So finding the appropriate balance between doing thinking, learning, that's hard because thinking is really hard. The internal and external stuff, there's stuff in that. So there's stuff externally, and I like the external stuff. People like to engage me in it, but I just can't do all of it. And then maintaining the personal and professional balance continues to be a challenge. And then, so I've been at long enough. The question, what about the legacy question? When is it time to think about my legacy? It may actually be too late for that. It may be that if there's really going to be a legacy, it's the stuff that I've put in place now that I probably didn't realize at the time. So I've talked too long. I thought I have to run off. I'll take some questions if you want. And I thank you all for your attention. It really is a privilege and an honor to me to be considered a maniac, I guess. I'll stop there. Thank you.
So please, some questions or comments.
I've got a question for you. Jack, I've seen you out there talking about earth science to all kinds of audiences. Do you think our message has had to change over the last 10 years, or do you think the environment's changed? Are people more receptive?
Well, I think our product has gotten so much better in the past 10 years, among other things, that, just from a satellite point of view, which is so much of the world in which I live. We've launched so many more over the past 10 years. We've got visualization capability like the hyperwall and stuff that we didn't have. We have results. So, it's an interesting dilemma because I think in general, people like what they do, like what we do. I think we do a good job. And, of course, it's always that because of the political sensitivity, there's some people who, they're just never going to buy it. And, I don't think rational intellectual conversation is going to change them, presenting the facts. So I think we may just have to accept the fact that there's some people out there that are going to, either not believe us or insult our integrity or whatever. One of the things that really is, just the fact that, when we're talking about, global change on a variety of scales, the ability to actually see what is going on the planet on multiple time scales, just the fact that we can do that is really amazing. I mean, it's a testament to the intellectual prowess of the community, the technical capability that we have, and in some sense the engineering that's enabled so many of our satellites to live very, very long lives. So, the things that we can show people, I think as my boss says, the fact that we can actually say this is good. If you go back 10 years, we look at what we're doing with GRACE for, Greenland and some other kinds of things, and some of the other areas where we can actually say, a number of people have probably heard me say, like a couple of years ago when we were using the different data to show, sort of Greenland scale surface melting. So, if it weren't for us, how would we even know? But the fact that we can actually see this and document it unequivocally, I think is great, and I think a lot of people appreciate and respect the fact that we do that for the world. Other questions?
Yep.
There's one back there, and if I don't know who you are, please say you are. That's not for retribution. I just like to know.
Well, I'm David Lagomacino. I'm actually an employee here, and I was just wondering what would you do differently in that sense? Were there any miscues? Were there any opportunities that you didn't take, or any opportunities that you took and that just didn't pan out?
Yeah, so the question is, miscues, things I might do differently, opportunities that didn't pan out. Now, one thing I will say from the point of view of funding research, research that didn't pan out doesn't necessarily bother me. If it didn't pan out for a good reason, if somebody was trying to do something, sort of high risk, high yield, and it ends up not working out, that's completely okay. Want to have a portfolio and some element of that is all right. For me personally, I tend to have a certain irreverent side. With the camera rolling, I try to behave a little bit, although Charles did tell me that, we can clean it up later. So every now and then I will get myself into trouble. So, there are probably certain times that I was trying to be funny and didn't always work. So that would be one thing. Probably other times maybe where, I didn't take that programmatic risk. Maybe I took the safe thing. But maybe I'm just not really capable of not really capable of introspection in a way that would help me really rigorously address that. I suspect you could probably ask people around here, and a lot of they'd be much more happy to come up with things that I should have done differently.
Jean Saubert, somewhat related to Pierce's question. I work on earthquakes and natural hazard, and we deal with probabilities of an earthquake, and people don't seem to fight us or like they do climate change. So it's back to why is one kind of have more of a political aspect than, earthquakes are also probabilities, but we'll tell people, okay, if you build this house, there's a probability of 10% there's going to be a large earthquake. And people say, okay, I'll build that house a little bit stronger. But when you talk about climate, there's just this political, irrational component that I still don't understand why it translates into climate change and not into natural hazards.
If you haven't read the book Merchants of Doubt by Oreskes and Conway, I would strongly encourage you to read that book, because that probably does as good a job as I've seen in answering that question. At best, I'm an amateur political scientist, so I probably don't know. But sort of when you really think about climate change and what it means to the nation and our economy, it's you can understand it being very threatening to some people, especially because if it means that you're having to deal with things like fossil fuel combustion and really deal with limitations on individual freedom and also the national autonomy to deal with a global problem. There's I think a lot of people, say me being armchair political scientist, that what does it, so if you're really talking about, you as an individual may be constrained, we as a nation may be constrained, to deal with things that come multiple generations from us that really are more globally focused than nationally focused. And why should we do that? So some people, I think, will fight the science, argue on the basis of the science, as opposed to, what I might naively consider as a more reasonable dialogue, which if somebody basically says, look, I understand that you're talking about this disease, so to speak, but we think we don't like the cure. The cure is worse than the disease, and frankly, we would rather take our chances with the disease than the cure. I'm not saying I would agree with that, but I can at least feel that that's a more rational basis for discussion than shoot the messenger and argue about the veracity of the message, which, then people will say to me, well, do you really believe in climate change? And it's like, hell yeah. So that's my armchair political science, but read Oreskes and Conway if you haven't. Art?
Jack, so regarding your discussion about training and education for scientists, I was wondering if, based on things that in terms of programs at headquarters and so on, whether mid-career scientists shouldn't spend some time at headquarters to find out exactly how the thing works and what the opportunities are.
I think
and whether they would, at some point in their career, want to go into management, and whether that wouldn't also help cement the relationship between Goddard and headquarters.
Yeah, I mean, I think it's a good thing. A lot of people have done that. You get some people, I think it's like, the minute that they're done with it, they're happy, they go running back to Goddard or whatever. And then there are people like me that never come back. And you know, we need both. So I think it's a good thing. You know, there's obvious challenges associated with doing it. You know, Goddard at least has the advantage of you don't have to physically move. If you're a crazy Virginian like me, it actually improves your commute for the time that you do that. But you know, I think it's a good thing, especially you know for the breadth depth kind of thing, because there may be no better way to get breadth perspective. But you know, for some people, if it's really a bad fit, then you know probably not. But I tend not to be a, you know, everybody should do something, you know, has to do something kind of role. But I think, you know.
But at least given the opportunity.
Yeah, I think it's something that people should take seriously. And historically, you know, we've had some from Goddard, less so in earth science, I think, than in other areas. But like, you know, Langley and Marshall in particular. And I think maybe because they're further away and they don't get in the middle of some stuff, I think they've seen it, you know, everybody's seen it more in their interests. To do that. So, you know, we may see more of that in the future. Right now, we've got, you know, certain challenges at headquarters in terms of, well, if somebody wants to come in and help, like I don't have an office for them. So that's, you know, we all have challenges, and, you know, management by real estate is one of mine right now. But, you know, if people are interested, I would strongly encourage that. But, you know, really think about it, especially, you know, how do you limit it? Because, you know, if you do it for very long, it is hard to get back. Any other questions?
Okay, Jack will be here for a little longer, so if you want to have more specific or personal questions, then you're welcome to come and have a chat with me. So with that, so let's give him one.